Good morning, space enthusiasts. Buckle up, because today is no ordinary day. Artemis 2 is launching, and it's a huge milestone for humanity. 4 brave astronauts are boarding the Orion spacecraft for a mission that will take them beyond Earth's protective magnetic shield for the first time in over 50 years. This one, zero-day lunar flyby, is more than just a trip around the moon. It's a dress rehearsal for a future moon base. The excitement is palpable. But then, of course, the sun decides to throw a tantrum. X-class solar flares, a coronal mass ejection, CME, shooting straight toward Earth. And suddenly, some experts are saying, whoa, let's delay the mission, let's hold off until late 2026 when the sun comes down. But is that really a smart move? Today, I'm going to break down why solar storms are dangerous, why we can't predict them perfectly, and why delaying Artemis 2 would not just jeopardize this mission, but potentially halt the entire future of space exploration. This is about much more than one mission. It's about the future of humanity's reach beyond Earth. Let's dive in. First things first. Artemis 2. It's a major leap for space exploration, a giant step forward in humanity's quest to return to the moon. But right as it's about to launch, the sun has gone into overdrive. The solar maximum, a period of heightened solar activity in its 10-year cycle, is in full swing. And just 24 hours ago, the sun unleashed a CME that made its way toward Earth, sparking beautiful auroras. However, the real concern isn't the auroras, it's the radiation that comes with these storms. For the Artemis 2 crew, leaving the safety of Earth's magnetic field and heading to the moon means exposing themselves to radiation that could disrupt communications, damage equipment, and even harm their health. The experts are worried that the mission could be too risky. But is that concern grounded in reality? Or is it an overblown reaction? Let's break down the facts and look at the real risks. Let's talk about solar storms, specifically coronal mass ejections, CMEs. These massive solar events are no joke. They launch billions of tons of supercharged plasma into space at speeds of millions of kilometers per hour. Inside that plasma is a deadly mix of solar energetic particles, mostly high-energy protons, that act like a radiation shotgun. Now, here on Earth, we're protected by our magnetic field and thick atmosphere. These shields deflect or absorb most of this radiation. In fact, unless a really massive storm like the Carrington event of 1859 happens, the radiation is largely harmless to us. But once you venture outside of this protective bubble, like the Artemis 2 astronauts will, there's no shield, no safety net. They'll be exposed. Now, Orion's hull isn't totally defenseless. It does provide some basic protection. It's compact and dense, but that's just the baseline. When a major solar storm hits, that level of shielding won't be nearly enough. Without extra protection, the radiation from a strong CME can quickly overwhelm the spacecraft. In fact, the worst 5 to 10% of solar events we've seen in the space age could deliver radiation doses that rapidly climb into dangerous levels, the kind of radiation that triggers acute radiation syndrome. You're talking nausea, vomiting, crushing fatigue, immune system collapse, and in extreme cases, organ failure. Even if the crew survives without immediate harm, the long-term effects are just as grim. Increased cancer risk, possible damage to the brain, and long-term health problems that could make future missions even more dangerous. This isn't science fiction. This is real. This is exactly why Apollo astronauts got lucky. Solar activity was relatively low during their flights. But now, we're in solar cycle 25, and the sun is at its grumpiest. Just days ago, an X-14 class flare erupted, and the solar radiation burst into space, lighting up the news. Artemis 2 is going to be flying right through this volatile period, facing this very danger head-on. But this isn't the end of the story. As dangerous as solar storms are, there are ways to mitigate their effects, and NASA has already put systems in place to protect the crew. Let's dive into those defenses. So, while solar storms are certainly a threat, NASA has a game plan. Orion isn't just a basic spacecraft, it's been designed with solar storms in mind. Enter the Solar Storm Shelter, one of the most innovative aspects of the mission's design. Instead of relying on a heavy, permanent, lead-lined vault that would add tons of weight to the spacecraft, NASA created a system that uses what the spacecraft already has. It's a flexible, dynamic solution that converts the spacecraft's own storage into a shield. The way this works is genius. Orion is equipped with 6 hybrid electronic radiation assessor (HR) sensors that measure radiation levels in different parts of the spacecraft. The sensors are placed strategically throughout the crew module, tracking real-time dose rates. Each astronaut also wears a personal crew active dosimeter (CAD), which gives precise data on their individual radiation exposure. With this system in place, the crew and ground teams can monitor radiation levels closely and react before things get out of hand. What's even more impressive is that NASA has set up a 24/7 monitoring system that tracks solar activity. They're pulling data from satellites, including Perseverance, on the far side of the Sun to provide early warnings. The beauty of this system is that solar storms typically build up over time. That gives analysts the ability to predict and give the crew 30 to 60 minutes of warning before things get dangerous. When radiation levels hit a critical threshold, Orion systems send alerts to the crew. At that point, they have about 30 minutes to move into the central stowage area of the safest part of the spacecraft. Here, they use the spacecraft's supplies, food bags, water containers, and even trash bags to create a makeshift barrier. This pillow fort is designed to absorb and block the incoming radiation. The crew huddles inside this protective shield, which is built in under 30 minutes and provides hours of protection. NASA's tests show that this solar storm shelter works. During Artemis 1, they tested the system, and the results were promising. Using real data from solar storms, like the October 1989 event, NASA's models suggest that once the crew builds the shelter, the radiation exposure will stay well below the threshold for acute radiation sickness. This means the crew can survive the storm with minimal harm. This mission is the perfect time to put this system to the test under real conditions. This isn't a dry run. This is a chance to see if the system works when the sun is at its most active. On day 8 of the mission, the crew will run a full shelter building drill in zero gravity. They'll practice the exact procedure they would need to follow in case of a solar storm. This isn't just about showing that the shelter works in theory, it's about making sure it works in practice. NASA is proving that they've prepared for the worst-case scenario. The goal is clear: to ensure that astronauts are safe, even when the sun is throwing its worst at them. But what if Artemis 2 is delayed? If we don't take this opportunity to test the system, what happens to the future of space exploration? How will we handle a solar storm when we eventually set up a base on the moon or send humans to Mars? We have to test the shelter now to understand how it performs under real-world conditions. If we delay Artemis 2, we lose valuable time to address the challenges we will inevitably face on future missions. Delaying Artemis 2 because of the sun's unpredictability sends the wrong message. If we reschedule this mission, we are saying that we are too scared to face the dangers of space. That's not just about one mission, it's about the future of humanity's exploration of the solar system. If we're going to send astronauts to the moon, Mars, or beyond, we need to be prepared to handle the risks. A solar storm is one of the most significant threats we'll face in space, and we can't afford to keep kicking the can down the road. The truth is, we can't accurately predict solar storms. While space weather forecasting has improved, the sun is still chaotic. Solar flares and CMEs can come from sunspots we haven't detected or from the far side of the sun. We can't wait for the sun to be calm before we embark on these missions. We need to accept that space is dangerous and learn to engineer solutions to protect astronauts. That's what this mission is all about, testing those solutions so we can move forward confidently. If we don't test Orion's solar storm shelter now, we'll be unprepared for future missions. We can't afford to keep delaying. The risks are always there, whether it's now or 6 months from now. We either face them head-on or we abandon space exploration altogether. The time has come for NASA to press forward. Delaying Artemis 2 is not an option. We have to test the solar storm shelter under real conditions so that we can be ready for the bigger missions ahead. If we delay this, we're giving up on the dream of a permanent base on the moon and a human presence on Mars. These missions are vital for the future of humanity. If we can't handle a solar storm during a 10-day lunar flyby, how will we manage when we are living on the moon for months or traveling to Mars for years? The decision is clear. Launch Artemis 2, test the storm shelter, prove that we can survive in space, and that we are ready to live and work on the moon and beyond. The alternative is simple. We give up on space exploration and tell future generations that the moon was just a one-time thing. I don't want that to be our legacy. Do you? Drop your thoughts in the comments. Should we delay or press ahead? Smash that like button if you're part of Team Exploration, and subscribe for more updates on the future of space. Let's keep pushing the boundaries of what's possible.